Okay, week 12, and we might almost make it to the end of semester with still some people in the room. Who knows? By Wednesday there'll be no one left, and that'll be an appropriate end to the semester. Alright, no, there will be people here because on Wednesday we tell you about the final exam. That's the blackmail to get everyone to come along again. Alright, so assignment 1, Andrew finally sorted out the auto marking. You wouldn't believe how many times you generally have to run auto marking before you finally get it right and cope with all of the weirdo things that students do. But now done, so now the tutor's doing hand marking, which means they go through, they look at your code, they look at the style, they look at whether the auto marking has penalised you too heavily, and they adjust the mark accordingly. So Andrew was hoping that you'd be able to use the feedback from assignment 1 to help you with assignment 2, but you've probably all finished assignment 2 by now, he says. Anyway, keep working on assignment 2. Hopefully you'll get some feedback in time to adjust what you've done there. And he's adjusted the deadline to Sunday, 4th of June, which seems quite late. When is that? End of next week. Alright. Of course, you're not off the hook just yet. There are 2 exams coming up. Prague exam, which is the one on linked lists, which will happen, I think, either at the end of this week or at the end of next week. Pretty sure it's the end of week 13. There's a course survey which only 30 people from this class have filled out. It'd be nice if more people filled it out. As I mentioned last time, the uni doesn't seem to care what the result is. They seem to care how many people filled out the survey, so fill it out. And of course, we'll talk about the final exam in the Wednesday lecture. Alright. Assignment 1, something we should have done 3 weeks ago, yes.
The exam is the final exam happening or?
No, the final exam will be in the labs. 3 hours in the lab. Part of it will be prac questions and part of it will be written, where written means typed. Which means we don't have to read your rubbish handwriting, which is one good reason for holding exams in the labs. And if you're like me, you've probably forgotten how to handwrite anyway, and it's really slow and painful. Anyway, so assignment 1, we're meant to take a look at some of the submissions. Andrew sent me a bunch of submissions, which he said were the 6 best, which passed all the tests. I think that was the definition of best. When I started looking through them, I discovered that most of them were reasonably readable. Some were designed reasonably well, but a lot of them could be improved. Even though they got full marks for everything, there's not just the fact that it's correct, but the fact that it's well written, well designed, and so on. So I thought I'd actually take a look. He wants us to look at them, and he's got all the names on the submission so we can pop them up and say, oh, look at that rubbish code by blah, blah, blah. I didn't think that was such a great idea. So what I decided to do, maybe for next time, I'll remove the names, make them anonymous, and we can have a look at them that way. But one thing that did strike me while I was reading them was that you hadn't done ADTs before assignment 1. And there are a couple of places where ADTs would have absolutely nailed what you were trying to do and made your code a lot simpler and shorter and cleaner. So I thought I'd take a look at that aspect of the assignment. So, before I do that, what else did I have to say? I made a few notes about stuff that have been done. Come on, network. You can do it. I pushed the button. Thank you. All right. And let me see. I'll just pop these open, because these were going to be my suggestion for making the assignment easier. What have I got open? Alright. Okay, one thing that I saw, thank you Andrew, who is using C99 stuff, and I abused him this morning for doing things this way, and he said, look, it's C99's been around for 18 years, why aren't you using the constructs that it provides? And indeed he provided these constructs in some of the lab templates, so I guess you're allowed to use them, but basically the deal was you can create arrays using the current values of variables, which will create an array of the appropriate size depending on what values these have been assigned. Back in the good old days, that would have generated a compiler error, because you weren't allowed to define arrays using variables to specify the dimensions. So what do you do if you're stuck with a rubbish old C compiler that doesn't support C99? How do you actually implement that if you can't do it that way? So I'll take a look at that. And also, while I was reading through, I saw a lot of people writing functions that had large numbers of parameters, and it struck me that we didn't really need that many parameters for a lot of them if we structured things differently. And in particular, if we define some kind of image data type that packaged up the height and the width and the pixels all in a single data structure, and you just pass that around. Okay, so that's what we were talking about with ADTs last week, so this is a nice example of how you can make code cleaner by the use of an ADT. So, what I decided to do was have an ADT for PBM, I think it was PBM format images, I hope it was, something like that. And so standard ADT, we got a pointer to some kind of structure that we don't know what's in it. And we've got some operations on values of that type. So, what do you reckon? So the first thing I want to do is think about what's the interface going to look like? What's the create function likely to do? Yeah? Are you holding your arm up to give a suggestion, or just pointing it? Okay. That's fine. Alright, so typical create function that we have been using so far has been something that returns a value of the type. Okay? So, and just because every other ADT has a create function, we need to distinguish this one, so we prefix it with PBM. Right, if you're going to create an empty image, you have to create it to be a certain size. So there are going to be two parameters, I would suggest, the height and the width. So this is going to create a PBM object that's completely blank, so all the pixels will be 0. Alright, so now think about the interface to reading an image. So what's likely to be passed into something to read an image from a file? I would suggest that the input is going to be a file star, and the output from this function, the return value from the function, is also going to be one of these PBM. Actually, that's is going to be a PBM image, and I shouldn't have put a star there, I should have complained. Because PBMT already has the notion of a star, not a pointer. So I'm going to create a completely empty image of a certain size and return the structure, or return a pointer to the structure that represents that image. And here I'm going to pass in an open file pointer. I assume it's been open for reading. And I'm going to return an image that's derived from reading the contents of that file. So it's going to read the height and the width, create an empty image, and then read the file and fill it up. Another thing that I saw, in particular, one of the assignment submissions that I looked at, there were half a dozen places where there was exactly the same chunk of code for making a copy of a pixel array. It struck me that it could have been more easily done if they'd made a function to copy the pixel array and just call that in those 6 different places. And then I thought, maybe we don't want to always copy the whole pixel array, because I saw some people were finding bounding boxes and they were just copying the bounding box part. So I thought maybe it'd be nice if we had a function to copy part of an image. Alright, so certainly it's going to return a new PBM image. Copy. And actually, if I want to be consistent with my naming conventions, I probably should have called it something like that. Alright, so what are the input? Well, one of the inputs is going to be an existing PBM image. And I'm going to return a new image, and the new image is going to copy part of the existing image in a certain region. So a way of specifying a region might be to specify the top left corner and the bottom right corner. That's how you look at it. So figured top left X, top left Y coordinate, bottom right X, and bottom right Y. Now something that, well, in bottom right Y, and probably I should have written those parameter names out in full so it's obvious what they are. Right, one thing that I did notice with a lot of you, and it was something that would have been handled had we had a style guide, because the old COMP1511 style guide used to say, never make your lines longer than 72 characters. So you don't get them wrapping the way this has. And so possibly some way of handling that might be to do something like that with the, I'm not using VI, I'm not using VI, I'm using GED. Right. So take an image, an existing image, and copy from the top left to the bottom right, copy that region of the existing image. Of course, you probably want to do some checking. The top left and the bottom right were actually inside the bounds of the existing image, and so on and so on. For one thing, a lot of times people were copying the entire image, so that's fine. I would argue that we could also have a function that would simply copy the entire image. And that'll be related to the PBM copy function, and hopefully you can see it's going to be related in a pretty obvious way. We just set the top left to 0, 0, and the bottom right to height -1, width -1. And then invoke the PBM copy function. Right, well, I reckon if you had those 4 functions, it might have made some of your code a little bit simpler to write, if you can just invoke those functions rather than having to repeat the code, you know, with nested for loops in a few places. Any suggestions for a different interface or extra functions that might have helped with the assignment? No? You think those would have helped with the assignment? Certainly in some of the assignments I saw, that PBM copy definitely would have helped. Alright, let's take a look. So that's all very nice. That's the interface we want, and we assume that's going to help us a little bit writing the rest of our code. So what about implementing it? Ooh, so we go to the implementation page, and let's see if I can do that. Beautiful. All right. So I'll just convert these signatures into actual functions. Ooh. Just get rid of that. All right. Now there's one more. The other thing I noticed in a lot of your code was that you do the function header, put that at the end of the line, and then leave a blank line and then start the code. I reckon that's a symptom that you actually want to separate out the function header from the rest of the code of the function, which is why I've been writing all my functions like that. Okay, so all right, we've got templates for all the functions now. What about the actual data structure? That's kind of obvious because in all of the examples you kept passing around an array of pixels, a matrix of pixels and a height and a width. So we simply bundle all those things together. Right, if we're going to create the matrix of pixels, then hopefully you remember from when we were dealing with malloc and matrices before that a two-dimensional array can be represented by a pointer to a pointer. Now the first pointer points to the first row, and the first row of the matrix is represented by a pointer to the first element of that row. Should have done a diagram of that, but basically we've got a pointer to an array of pointers, and each of those pointers points to an array of elements. Okay? So that's the data structure that we're going to build. Alright, so first thing to do, we need to create let's just call it pix. Right, what do we need to create? I said this two-dimensional array is represented by an array of pointers where each pointer points to a row, which is an array. Alright, so the first thing we need to do is to make that array of row pointers. How many are there? Well, there are a height of them because there are height rows. And how large is each of the elements in that array of row pointers? Well, it's going to be the size of an int pointer, because each of those elements in that original array, if you like, is a pointer to the first element of a row. So it's a pointer to an integer. So that will give us our initial array. Actually, I'll probably... Oh, that's right. So I'll do that. And I guess I can use assert to make sure that the malloc didn't fail. Okay? So we've used assert a couple of times, and of course we need to do all of our usual hash includes. PBM.h. And if we want to consistently put all of the system includes first, then we could also put assert.h first. Generally, it doesn't matter what order you put the asserts. However, in this case it would, because pbm.h has a reference to a file start, and if we don't explicitly include standard io.h first, then when we come to process pbm.h, we would end up with an error. Now, another way of dealing with that potential problem is to indicate explicitly in pbm.h that we're going to require some data types from standard IO, which now makes that legal no matter where pbm.h is included. Now, of course, I mentioned last time that we have this potential problem that if I do this hash include standard io.h here, and I'm doing a hash include standard io.h here, and then I do hash include pbm.h, then there's the possibility that things can end up being multiply defined. So the way to handle that, well, standard io.h already handles that, but in general, if you want to protect these .h files from accidentally being included multiple times, then we do this little trick at the start. So if we've never included this file before, if this symbol hasn't been defined, then we include the rest of the code and we make sure that that symbol is now defined. So it doesn't matter if someone goes hash include pbm.h, hash include pbm.h, hash include pbm.h, only the first one will actually be included. And I need to close that hash if and if down the bottom here. Right, so one thing that allows us to do, it allows us to kind of write sensible things that we actually want to write. We want to indicate that pbm.h is using stuff from standard IO. So it makes sense to include here standard io.h, so that then we're allowed to do that. You probably don't want to rely on the fact that standard io.h has been hash included before pbm.h, because someone might write some code where the main program doesn't use standard io.h at all. And so that's a potential problem. Or, in fact, we can't really avoid using standard io.h here as well, or hash including it, we've got that. So that little trick of including these two lines at the start of any .h file, and conventionally we just use the name of the .h file with an underscore replacing the dot to indicate, all right, this file has never been included before, I'm about to include it. Once I've included it, I don't want it to be hash included again. All right. So, we got to the point, we've mallocked the original array that points to the array, points to the rows. All right, now we need to allocate each of the rows, so that's going to require a row variable, if you like. And that's rubbish. That's the number of rows. Okay. So for each row, what we need to do, we need to allocate the array representing that row. And we're going to do that by saying pix I. So each row is with integers. And once again, we'll do an assert just to make sure. Hopefully these asserts are never triggered. We always manage to allocate space for the thing that we want. And then maybe just maybe we want to zero things out. However, there's an easier way than writing a for loop to do that. And that requires us to use a different version of malloc called calloc. So this thing here will allocate space for that many objects of that size. So rather than having to do the multiplication like we're doing, we actually just say, I want this number of objects of size of int. Okay? And the other thing that calloc does that malloc doesn't do is it actually zeroes out all of these objects, which is the effect we wanted. So we can actually do that a little bit quicker. We could have easily written a for loop. You know, we could have done this. And you'll say, well, since it's so easy, why didn't you just do that? Fair comment. Could have done that. But a quick way of doing it is this, and I may as well, I'll leave that in place and I'll just comment it out. And here's the alternative version. And as a lazy C programmer, I want to write as little code as possible. So you can see the slightly annoying discrepancy in the calling sequences of calloc and malloc. Malloc you explicitly have to multiply, so the argument to malloc is the number of bytes. Okay? The argument to calloc, well, there's two arguments to calloc, the number of elements and the size of each element. So it still generates exactly the same amount of space, but calloc goes through and clears everything out once it's allocated the space, which I think you'll argue is a little bit simpler than writing what we did before, but we still need to check because underneath everything it's still doing a malloc, or it's doing a malloc-like operation, which may end up failing. Right, so let's see, what do I need to do to finish this off? So that's created, I forgot to do something important. Alright, so anyway, I've created the array. The next thing I need to do is actually create the PBM object. I hadn't done that yet, so I'll do that now. So remember that PBM underscore T is a pointer. So I'm allocating one of these structs and I'm setting the values in it, height. It's going to be equal to the height value that I passed in. Remember last time I said C's quite happy for you to use the same name, but you're using it in two different contexts so it understands what you're talking about. Yep?
When you use calloc, you don't initialize it.
You don't need to. Calloc initializes everything. That's the whole point of calloc. It's sort of like do a malloc and then clear everything. So, yeah. So that'd be a reason for using it. It saves you having to write that for loop explicitly. But if you want to write that for loop explicitly, that's fine. Actually, another thing that I noticed while I was looking at the code, a few people, I don't know if they're in this lecture, they were copying what I did and putting single statements at the end of the for loop, and that creates very long lines, which isn't a good idea. So don't do that. Do that. If you can't be bothered putting the braces, at least put the statement on the next line. All right. So the width, and then finally, I forget what I call it. I think I call it pixels. might say, "Are you sure that's going to work?" And I'll say, "Yes, I'm sure it's going to work." The type of pix is int star star. The type of pixels inside the struct is also int star star. So there's the same kind of value. So all I'm doing is copying the pointer for pix into the structure component called pixels. And of course, finally, I need to return a pointer to that struct that I just created. Alright, so that will do everything I need. And if I didn't have this in, the whole function would be relatively short. Any questions on that? Yeah. You could, but there's not really much point, because you're going to have to run through and change the values of all the objects that you called anyway. So could, I mean, presumably calloc is a little bit slower than malloc because it's actually doing more work. I don't know, maybe it's not, but you know, if I do calloc up here, sure, calloc height, comma, size of int star, it will allocate a whole bunch of pointers and give them the value 0, which is going to be treated as null. And then I'm running through and I'm changing the values. So there's a bit extra effort that you don't actually need. Anything else? No? Good. All right. So next thing, we want to read in values into a PBM file. I didn't even look at Andrew's PBM read, so I'll just be making something up. And I remember that he did have an extra function that would read in the height and width data, but since this is supposed to be reading in the whole lot, let's do that. Let's do that interestingly. Alright, now one thing that I was about to do I think the first line of a PBM file contains two numbers, which are the height and the width, is that right? You should know, or you didn't even look. You just, this is interesting. So if you just use the get PBM height width, whatever it was, function without even looking, that's fine. I don't trust scanf because I'm never sure where it's going to leave the file pointer after it's finished. And I have a bad feeling that if I wrote fscanf like that, that would be wrong anyway, because I'm supposed to have something like that. If I wrote it like that, it would leave the file pointer at the end of the line, and if I happen to have some extraneous spaces at the end of the line, it would see all of them as well. And then, in the next part of the function I'm going to go through, I'm going to read what's in the file, and if I do that, then I'm going to read those spaces, or at the very least I'm going to read that new line and treat that as one of the pixels in my pixel array, which is no good. So rather than using fscanf, I never use scanf or fscanf unless there's something really trivial and I'm going to just read a bunch of integers or something. So what I'd rather do is use fgets, and I probably should have thought of a name, and of course I can never remember what order the arguments are. And if you're like me, then you can easily find out just by doing fget. So the array, the size, and the string in other words, the file that you're reading from. So I actually managed to get it right. And the other weirdo thing to notice, fgets actually returns the char star, and generally it returns that value, which you might think is pointless because you already know that value. However, if there's no input to read, it'll return null. So that's occasionally useful for recognising that you've reached the end of the file, or that you've tried to read and there's actually no input to read. So if I wanted to be really paranoid, I could put an assert and check that fgets did not return null. Looks a bit weird putting the fgets inside the assert, but works fine. So read in the first line and make sure that you consume the entire line, including the new line character, and then you're positioned at the start of the next line, which presumably is where the first pixel is located. Alright, so we've got line, so we can't use fscanf, but we can use scanf, which effectively does the scanf, but the input comes from a line buffer, or from a character buffer. So that's going to work alright. Any questions on that? Try to avoid scanf if you can, unless you're simply doing scanf %d, scanf %d, scanf %d, or something like that. Then it's alright. But otherwise, if you're mixing up reading characters and reading integers, then you need to be a little bit careful about what scanf is going to do for you. Alright, so what have I achieved so far? I've read in height and width. What am I going to do with that? Well, I'm going to create a PBM. I'm going to create an image. And I've already got a function for doing that, so I may as well use it. Now this is doing a bit of unnecessary work as well. It's zeroing everything out, but I'm about to write over the top of that. But it simplifies this function quite a lot. Right, now I didn't read the read PBM read, whatever it was, function that Andrew gave me, so I'm going to make one up. So what I'm assuming is that the rest of the file consisted of a sequence of characters that were either 0 or 1, and they determined what the pixel value was in the pixels array. So, how to deal with that? Well, we've got a line buffer. Ooh, ho, ho, ho. Alright, I was going to use the line buffer, but I won't. I'll use character at a time. And I'll use the standard C idiom for reading a file character by character, which is that. So this is exploiting the fact that an assignment statement also is like an expression in that it returns a value. So this calls the function getChar, assigns the next character to the variable ch, and returns ma. Ooh. That was a bit weird, wasn't it? And returns the value that it's assigned to ch into this part of the expression and compares that to EOF. Okay? So basically that's how every C programmer writes. Read a file character by character. Alright, so what we need to do here is we need to be filling up the image pixels. So we're going to need some variables. Maybe I'll call them row and column because that will make it more obvious what's going on. Right, so what do? I've got a character, it's not EOF. There are three possibilities that are interesting. One is that it's a 0, one is that it's a 1, and one is that it's a new line character. So for a new line character, so once again I said I'm making assumptions about what these PDM files look like. So if it is a new line character, then what I need to do is basically I've reached the end of a row. So I need to go back to the start of the next row, and that involves doing two things. One is to increment the row, and the other one is to reset the column to 0. So I'm going back to the start of the next row, if you like. Otherwise, I guess and if I remember, if you notice, the pixels array is an array of ints. It's a bit of a waste of space actually, because we're only doing 0 and 1 for the values, but in any case that's what we decided to do. So if the next input character is 0, then go to the pixels matrix, to row and col, and set that to 0. Now I don't just want to assign it to CH, because even if CH is a digit 0, that's not the value 0. Okay. So that was the reason for doing that. And the other thing we need to do, we need to advance the column counter. I guess another thing that we ought to do just in case someone gives us dud input, so they put all of the pixels on a single line. Now I don't remember if that's what the format was, but I'm assuming it's not. We've got an array of zeros and ones. I suppose I could have gone and looked at the files, couldn't I? Alright, another possibility is that it's character 1, in which case, once again, before we do that, I was just going to do something naughty, but I won't. Yeah, we're going to end up doing almost the same thing twice. Same chunk of code, one difference which doesn't exist yet, but will in a moment, is that there I'm assigning 1 rather than 0. Now you might look at that and go, that's a bit of a waste, you're writing the same thing twice. You can compact that, and I'll show you one way to do that. No, it's only 3 lines of code, so maybe it doesn't matter so much that we've repeated, but if you're really annoyed about having to write the same thing almost twice. The other thing I should add is that if we see something that's not a new line, not a 0, not a 1, then we've got a problem. So at this point perhaps you could fail and say, alright, this is an invalid file. And one easy way to do that would be to stick an assert in here. Because we know for sure that that assert is going to fail. So if we ever get to that else, we want the program to fail out. Right, so just to make it clear, what I'm assuming is that the file looks like something like this. So let's say we've got a 4x4. So we've got an image that looks something like that. So that's what we're going to be reading. So this ought to process that kind of image appropriately. Now, I said that we could do this a little bit simpler, so let me stick in the more compact version. So we comment that out. Put a new version here, which handles both of those cases. You may say, that doesn't really save us much because we've still got to decide whether it's going to be 0 or 1 at this point. So we're going to have to stick an if statement in here anyway. Well, no we don't, because C has this notion of a conditional expression where you can write, it's a ternary type thing. So it's got an expression component and it's got two values. And what it does with this expression, it evaluates the first expression part, and if it evaluates to true, the result of the entire expression is the value of the first, or the next component. I'm going to write that down. So basically what we've got is a condition So this is what a conditional expression looks like. So it's got three sub-expressions. The first one is something that gets tested. The second one is just a value, and the third one is also just a value. So we evaluate this first condition. If it's true, then the value of this whole expression is the value of exp1. If this evaluates to false, then the value of this whole expression is exp2. Okay, so it's occasionally useful to avoid having to write sort of trivial if statements. So in this context, we can do something like, well, this is is it going to overflow the line? Oh, cheap. There you go. Right. So getting into this part of the code, I know that CH is either 0 or 1, or the digit 0 or the digit 1. I always want to do this check to make sure I haven't overflowed the columns. And actually, the other thing I should have done, just in case we're overflowing the row as well. Yeah, so if the character is a 0, then the value that's going to be assigned to this particular location in the pixels array is 0. If CH is not equal to 0, the value that's going to be assigned is 1. And that's the only other possible value. It's either going to be 0 or it's going to be 1. So notice that is definitely not the same as that, and that is definitely not the same as that. So we're doing a mapping, if you like. Actually, I guess another way of handling that, I just thought maybe something that's even simpler. What do I do? Here's another alternative. Oops. smart. But in any case, it gave me an excuse to introduce conditional expressions. So both of those would produce the same result, because it turns out that the characters 0 and 1 have adjacent ASCII values. So 0 minus 0 is obviously going to give you 0, 1 minus 0 is going to give you 1. Okay? So either of those approaches would do the trick. So I guess we could I think you can nest hash ifs this much. We've got a lot of alternatives floating around here. Right, so my argument would be probably the second one. It's simpler, but it only works in this case because we happen to be dealing with 0 and 1. Right, in any other context, maybe something like this would be more useful. Alright, so we're filling up the pixels in the array. Yeah, alright. One thing, we're only doing this assert in one location. Yeah. Now, of course, this function would be a fair bit shorter if I didn't have all this extra stuff floating around. And that really should say room. Alright, any questions on that stuff? I mean, it may be slightly confusing because I've got all these hash if zeros and hash else's, but if you look at any reasonable sized piece of code, you're going to find a lot of stuff like that. Maybe not hash if 0, but maybe hash if def in some particular computer architecture or something like that. Alright, let's have a break, and I'll continue that after the break and then talk about a couple of other things.